In this problem, we need to prove the following. So let's begin from the left hand side of a given expression. So here we have cosecant theta. We know that cosecant of theta, that is the reciprocal of the sine function. So we have 1 over sine theta. So we're going to replace cosecant of theta with 1 over sine theta, whole multiplied to, now we have secant theta minus 1, but secant theta, that is the reciprocal of the cosine functions. We have secant theta given by 1 over cosine theta. So let's plug in this value here. So we have 1 over cosine theta minus 1. Minus, we have cotangent of theta, which is the ratio of the cosine over sine functions. We have cosine theta divided by sine theta, whole multiplied to 1 minus cosine theta. So that will be now equals to, so we will multiply 1 over sine theta with 1 over cosine theta minus 1. So that gives us 1 over sine theta times cosine theta minus 1 over sine theta. Minus, so we have cosine theta over sine theta multiplied to 1. So we have cosine theta divided by sine theta plus cosine squared theta divided by sine theta. Now let's combine all of the terms. So our common denominator will be sine theta multiplied to cosine theta. So here in the first term, we will have 1 minus, then the second term will be cosine theta. The third term will be cosine squared theta plus the fourth term will be cosine cube theta. Now we know that we can now combine the first and the third term. We have 1 minus cosine squared theta, and if we combined, if the second and the fourth term by taking cosine theta as the common factor, so let's take positive cosine theta, so we'll have cosine squared theta minus 1 whole divided by sine theta times cosine theta. Now this, we have two expressions. We have 1 minus cosine squared theta added to cosine theta times cosine squared theta minus 1. So if we take 1 minus cosine squared theta as the common factor, then the first term is going to leave us with 1, and the second term, so here we have cosine squared theta minus 1, so we'll take negative 1 as the common factor. So we have negative times cosine theta whole divided by sine theta times cosine theta. Now we know we have an identity which is given by sine squared theta plus cosine squared theta. That value is equals to 1. So that means 1 minus cosine squared theta can be replaced with sine squared theta. We have sine squared theta whole multiplied to 1 minus cosine theta divided by sine theta times cosine theta. Now sine theta from the numerator and the denominator cancels out, so we have sine theta over cosine theta, which will be equals to sine theta whole multiplied to 1 minus cosine theta divided by cosine theta. Now we can rewrite this expression as sine theta divided by cosine theta minus sine theta times cosine theta divided by cosine theta. So here cosine and cosine gets cancelled. Sine over cosine, the ratio is tangent of theta, and we get tangent of theta minus sine theta, which is the expression on the right hand side. Hence we have successfully shown that the left hand side of a given expression is equals to tangent theta minus sine theta on the right hand side. Hence proved.